In this exercise, we show that as x approaches -3, this function has a limit of 8. And we're only going to use the basic definition of convergence of a function. So to save a little writing, define f of x to be our function. Now this represents the distance between the function evaluated at x and the limit 8. Rewriting it here, and then canceling the 8's, we get x squared plus 3x. Factoring out an x, we get x times x plus 3. And then using the properties of absolute value, you can write that as the absolute value of x times the absolute value of x plus 3. Now notice that this expression represents the distance between x and -3. So if we require that distance to be less than 1, that allows us to set a bound on the value of the absolute value of x. And thus we'll be able to show that this expression, which is the distance between our function and 8, will be less than some arbitrary epsilon. So if we require x to be within 1 of -3, then rewriting the absolute value of x as the absolute value of x plus 3 minus 3 allows us to use this fact. Next, we're going to use the triangle inequality, which is one of the most important properties in all of analysis. And that allows us to say that this expression is less than or equal to that expression split up into the absolute value of x plus 3 plus the absolute value of a -3, which of course equals the absolute value of x plus 3 plus 3. We've shown this is less than 1, so this is less than 1 plus 3, which equals 4. So now we know that the absolute value of x is less than 4 if x is within 1 of -3. So given any arbitrary epsilon greater than 0, we will define delta to be the minimum of 1 and epsilon over 4. And the 4 comes from the bound on x. And we'll see how that works out nicely in the algebra in just a moment. And for all x, such that x is within delta of -3, we know that then x plus 3 has to be less than 1 because delta is the minimum of these two values. And we've already shown that if x is within 1 of -3, then the absolute value of x has to be less than 4. So now we have everything we need to complete the proof. It follows that for these x, the distance between the function evaluated at x and our limit of 8 equals, we've already shown this expression equals this, so we'll just substitute that in here. We know that the absolute value of x is less than 4, so we'll substitute here. We set a boundary on x plus 3, so we can substitute in delta. We know that delta is the minimum of these two values, so delta has to be less than or equal to epsilon over 4. 4's cancel, and we get epsilon. So we've shown that for any epsilon, there exists a delta such that the distance between our function at x and the limit of 8 is less than epsilon. Therefore, the limit as x approaches -3 of our function is 8.